Do you see this little device in my hand? This is an SSD, and if you think that this is not important for the overall performance of your gaming device or your PC, you are wrong. In today's world, SSDs are expensive and hard to get by because the price of storage has gone wild. On top of that, when it comes to device performance, the quality and the type of SSD you have makes a huge difference when it comes to intensive tasks, like playing GTA 6 in the future. So before you drop a chunk of your cold hard cash, not that kind of cash, or if you're binning an old device that might have one of these old drives in them, let me walk you through what is actually happening, what you might be missing out on, and the most important things to know before you buy new SSDs or recycle new SSDs. If you have a bunch of these things lying around, or if you have old devices, stick around till the end and I'll show you how to repurpose some of these drives to something a bit more functional and get a bit more life out of it. And if you like these kind of videos, please do hit the bell icon, subscribe, like, comment, because it really helps my channel. Thank you. Okay, so the first big question is that why is the prices of SSDs going up so fast? And the short answer is AI, or artificial intelligence. You see these massive warehouse type buildings that run your AI models like ChatGPT? These are called as data centers. And data centers require a staggering amount of storage and power. For storage, these big companies buy all the storage SSDs out there, and when they grab all of the supply, there is less of it left for everyday customers like you and me. So when the demand is high and the supply is the same, that drives up the prices. So the actual chip inside your SSD that makes it valuable is called as NAND chips, and NAND stands for not AND, which is basically a fancy term for a logic gate that stores all your memories, files, and all sorts of stuff that you want to store in your SSD. And to manufacture NAND chips, it's a very complex process and it is not very simple. So not a lot of manufacturers actually do that. Currently out there in the market, there may be 3 or 4 major players, including Kingston, SanDisk, Micron, Samsung, and maybe others. And they have all reported that the availability of NAND chips are in seriously low supply. How low? Well, Kingston have reported that the prices of these NAND chips have gone up by 246% over the last year. Micron, on the other hand, are not even taking orders because the market is so chaotic. I myself have personally felt it at work. When I was talking to my IT department, they told me that any new laptops or computers landing on our desks are costing at least 20% more than the last year, and that is absolutely brutal. So if it feels like storage has got expensive, you're not imagining it. It's actually true. Drop a comment in my comment section and let me know when was the last time you bought an SSD and how much did you pay for it. I am genuinely curious to know how much the prices have jumped for you. Okay, so if the prices are high, I want you to make a smart choice. But here's the catch. Every SSD label out there screams that it is blazing fast and it has amazing performance. But in reality, not every SSD is created equally. So let me break down all of these confusing fluff which you see when you want to go and buy an SSD, so that no marketing sticker can ever fool you. Let's start with M.2, which is basically the shape of your SSD. A lot of people get confused that M.2 might mean fast or incredible performance, but to be honest, it's not. It's just the form factor. It was originally called as NGFF, or Next Generation Form Factor, but then somewhere down the line, someone decided to name it M.2. And the numbers that you see next to it, 2280, 2242, 2230, that basically means the size of the SSD. So 22 stands for the width and 80 stands for the length. If it says 2230, it basically means this. So the 30 refers to the SSD length, that is around 30 millimeters. And that genuinely is M.2. It's the shape and the plug, and that's it. Let's move on to NVMe. So NVMe stands for Non-Volatile Memory Express, and that is a newer standard built for SSDs specifically so that they can handle multiple requests and be faster. You will also have SATA technology in this form factor, and you should avoid it at all cost. One way to identify the difference between NVMe and SATA SSD is the amount of notches on your card itself. If it has got one notch, it's an NVMe drive. If it has got 2 notches, it is a SATA based SSD, and you should avoid that. But obviously you've got these type of SATA drives as well, but it is easier to differentiate between them, and that should not be a problem for you. So the next thing that you will notice is something called as PCIe, and it is usually followed by something like Gen 4 by 4 or something like that. So think of PCIe as the highway between your SSD and your CPU, which is your computer's brain. The 4 in 4 into 4 stands for the amount of lanes on that highway. The higher the number of lanes, the faster your processing time is. So for most consumer grade SSDs, you'll get 4 lanes typically, and that is enough for everyday use. Generation stands for the generation of the drives, obviously. So you get Gen 3, Gen 4, Gen 5, and basically that is the speed limit on the highway. Let's have a look at the performance difference between generation 3, 4 and 5 and understand what it actually means. So in the graph below, you can see the read and write speeds for Gen 3, 4 and 5. Generation 4 sits around 7,000 megabytes per second and Generation 5 sits around 14,000 megabytes per second. It is megabytes, not megabits. Megabits is for internet, megabytes is for SSDs. So yeah, basically between generations, the speed roughly doubles. All these SSDs that I have got are Generation 3 because these were fished out of old laptops 3, 4, 5, 6 years old. But if you can get a hand on Generation 4 devices, you will really enjoy it. So the next term is IOPS, and this single-handedly is the most important metric that you need to look at when you're buying an SSD. If you're buying an SSD for like gaming purposes or rendering purposes or some sort of heavy-duty tasks. So IOPS basically means input output per second, and it is the measure of the amount of activities the hard drive can do in a second. So the big numbers that you just saw, 14,000 megabytes per second, that is sequential speed. That is like moving one giant file from one point to the other. But in reality, that's not the case. Think about what happens when a PC opens a game. It isn't grabbing one giant file. It is grabbing small files from each and every location within your SSD. System files, setting, textures, renders, colors, etc. Like all of those things are moving between your CPU and SSD at any given time, and this is where IOPS is important. So higher the IOPS, the better performance you will see in day-to-day activities like booting up your computer, launching a game, moving between tasks, etc. And this is where the difference is jaw-dropping. So don't get confused between the giant read and write numbers. Also take a look at the IOPS levels. In this graph below, I have shown you the different IOP speeds between different generations of SSDs. As you can see, Gen 5 SSDs have the highest IOPS because they are the latest. They can handle around 1.4 million IOPS, while a Gen 4 SSD can handle around 1 million IOPS. And these SSDs, these can only handle around 150, maybe 200 IOPS, which is actually quite slow. But here's a tip. Between Gen 3 and Gen 5, the IOPS level range around 600,000 to 1.4 million. But in a real world application, the difference is not that much. So unless you are rendering in 8K or playing some sort of a heavy game like GTA 6 in the future or whatever, stick to Generation 3 and 4 to save a bit of money, because in real world you will not see much of a difference. But if you're using it for an extreme application, go for Gen 5. If the IOPS have finally made sense, hit the like button, put a comment, subscribe, engage with this channel because it really helps. Thank you. Okay, so the next thing to know is NAND, and I have explained this to you previously, but NAND stands for not and this is the chip that you need to store all your data. This is the memory bank. This is where everything gets stored. It generally comes in 4 types, and it is based on how much data or bits you can cram in one cell. You've got SLC, which is single cell. You've got MLC, which is 2 cells. You've got TLC, which is 3 cells, and you've got QLC, which is 4 cells. As a rule of thumb, the more information you can fit inside the cell, the slower the cell gets, and the lesser it is durability wise. So you will find QLC in most consumer brands out there because you can cram a lot of data. It is cheaper to manufacture, but these drives are slower and have lower endurance. And SLC is the most expensive because it is the fastest and has a lot of endurance. And you will see those things in your server stations and data centers, etc. So basically, the more density of information per cell, the lesser the endurance and lower the price. And finally, DRAM. And this is the stuff they don't mention in most advertisements out there. So DRAM basically means dynamic random access memory, and it is the memory for your hard drive on your hard drive. So if your SSD has a DRAM, it basically has a map of where the data is stored in your SSD, and it is a game-changing feature if you are using an SSD for gaming applications. Drives without DRAM have to borrow some memory from your computer, and this is called as host memory buffer, kind of like a parasite. The ones with host memory buffers are often slower and less responsive. So here's the sneaky part. Most manufacturers will not tell you if their drives have DRAM or not. And this is something that you will have to find out using a third-party website or a Google review or something like that, because it is quite important when you're using your SSD for an intensive application like gaming, rendering, or video editing. Alright, so to summarize, here are the things that you need to know before you buy an SSD. First, you need to know what sort of purpose you are trying to achieve with the SSD. If your purpose is just memory backup, just transferring some files or light tasks, stick to Gen 3 or Gen 4 SSD. If you're thinking heavy gaming, 8K video editing, Gen 5 SSD is your go-to. Number 2, don't pay for older technology. Right now, SATA and NVMe drives cost the same. So make sure that you have an NVMe drive and not a SATA drive, because that's old technology and that's slow. Look out for the notch. Make sure that you have one notch and not two notches. Number 3, look out for the treasure map or the DRAM. Most manufacturers will have two similar products, and one will have DRAM and one will not have DRAM, and they will not even mention that in their spec sheet. Go on to third-party websites, ensure that you take the DRAM one because it plays a significant role, especially for heavy tasks. Number 4, you should know what sort of NAND you are getting into. So usually QLC is what you will get in most consumer drives, and that is slower and has less endurance. It is fine for storage purposes, but if you are using your SSD for an intensive task, go for TLC at least. Number 5, check the price per terabyte for your memory. Right now on many websites out there, a 4 terabyte SSD will cost lesser per terabyte than a 1 terabyte SSD. I know it's an upfront investment, but you save money in the long run. Number 6, do not panic buy. I know I've made this video about SSDs, but the prices are fluctuating and they go up and down as the demand goes up and down. Wait for the right time, set reminders, wait for Black Friday sales, etc. Stack up gift cards and rewards point, but try to not panic buy, because yes, the supply is short, but it can change at any given time. And finally, this brings me back to these little guys. I had a stack of old laptops which were dead and basically ending up in the recycling bin, but I asked my IT team to fish out these SSDs from them because this is basically a treasure. What I found was one 1 terabyte hard drive and about 512 gig drives. Now I know they are Gen 3, I know they are QLC or quad bits, but to me it is free storage. So the first thing that I will be doing with the 1 terabyte version is putting it in an enclosure like this. This is an enclosure that I bought from Amazon, and it basically houses your NVMe SSD and turns it into a portable storage device. All you have to do is plug your SSD in there, put some cooling stuff on it, and you're good to go. With these enclosures, what you need to look out for is the type of cable that you're using. Not all USB cables are created equally. I am using a USB Type-C to Type-C. However, using a slower cable is basically choking the performance on your SSD, and that is not what you want. So always make sure that you use the right cable, especially for these kind of applications. And backup is not the only trick that I have up my sleeve. You can use these things as a temporary scratch drive, wherein if you are editing videos or photos, for example, this YouTube video, I will point all my temporary cache files into this drive from my DaVinci Resolve software, and then that basically will keep my primary memory clean and fast, and my timeline scrubs will be much smoother. Another thing that you can do with these drives is create like a home server. So you get these NAS drives where you can plug in your NVMe SSDs and create a home server. In that server, you can store your favorite movies, TV shows, etc. and host it on your internet, and you can basically stream it from your home server. And in that way, you don't have to pay for your expensive Netflix subscriptions and Amazon Prime subscriptions. You can get it free of cost. Of course, I'll not tell you where to get your data, but yeah, I'll let you figure that out. I was thinking to do something similar at my house, but I have to find budget for a NAS drive, which I don't have currently. So see how we go. Tell me in the comments below how you use your SSDs, and if you want more such money saving tips, please hit the bell icon and subscribe. So there you have it. SSD prices are through the roof and they will stay up there for some time. But with a little bit of know-how and some knowledge, you can absolutely make the most out of the next SSD you buy. If you like this video, please hit the bell icon, subscribe, like, because this is the kind of videos that I like to create, where I try to explain complex things and things that I find interesting in simple ways. And if you've got a bunch of old drives lying around in your house and you know a better way to use them, please let me know in the comments below. Thanks for watching this video. I'll see you in the next one. Bye-bye.